Good morning, students. In our previous class, we discussed about Planck's quantum theory. Related to Planck's quantum theory, whatever the types of formulas are needed to solve the questions, everything in the previous class we discussed. Now, let us solve some numericals based on that Planck's quantum theory. Okay? There are very few types of questions they are asking in the competitive examinations. Let us discuss those questions. Now coming to the first one. First note down the question. The wavelength of radiation is 600 nanometer. Then calculate its energy. Okay, so wavelength of the radiation is given and asking us to calculate its energy. Okay, so what is the relation between energy and wave? Okay, if we observe the formulas yesterday, whatever we discussed is what is the main formula we know? E is equals to mh mu. This gives relation between energy of the radiation and the frequency of the radiation. Where n means number of radiations or number of photons. In terms of wavelength, the above formula we can write as mh mu. mh c by lambda. Because frequency is nothing but c by lambda. So these formulas, everything we discussed yesterday. Now, what formula we need to use here? Here, they are asking the relation between wavelength and energy. So directly we can use this formula. Okay? So before solving any question, as you already have experience in solving the questions. Okay? So first of all, avoid the worry about the solving the numericals. Okay? So if you have fear of numericals, definitely you are not able to solve any questions and you won't get good marks in the NEET examination. Right? You are not going to write for JEE advanced level. So you won't get the typical numericals. Already you have written the NEET examination and you have solved some previous NEET questions. You should have some idea. For NEET level, 100% they are asking the question simply based on the formula only. Okay? So very rarely out of 45 questions, maybe you may get one numerical or two numericals. Very, very rare case in a typical. Okay? So you don't worry about that one question maybe in the NEET exam. Okay? So better don't have the fear of numericals. When you are solving numericals, even in the theory part also, you will be perfect. Right? So from the starting time onwards, focus more on solving the numericals. Right? First of all, what information they given, let us write first. They given the wavelength of the radiation. Its value is given as 600 nanometers. Okay. For any question based on any topic, remember to focus on the units first. If you observe the other terms in the formula, we need to take Planck's constant. Right? So, better always to take the wavelength in terms of meters. Because the velocity of light will take in meters. That is why better to convert the wavelength into meters. Right? Sometimes they may give wavelength directly in the meters, or they may give it in angstroms or nanometers or picometers. Already I have given the data how to convert these angstroms or nanometers into meters. We all know that 1 nanometer is nothing but 10 to the power minus 9 meters. Okay? So first let us convert this nanometers into meters. So lambda is equals to 600 they given. Now we need to multiply the given value with the 10 to the power minus 9. Then we will get the data in terms of meters. Okay. So after multiplying 600, 6 into 10 square. 10 square into 10 to the power minus 9. It will be 10 to the power minus 7 meters. Okay. Somebody or you may already done some mistakes, because by looking at the question first we will focus on the formula. So everyone will write that E is equals to Hc by lambda. H we know, C we know, lambda they given, they will substitute. Corresponding option will be in the first. So that option we will choose blindly. But after getting the result we will come to it. Okay. So first focus on the units. Wavelength should be taken in meters. Now H value. H value we can take it in terms of joules as well as in terms of hertz. Most of the cases the options will be in joules. If the options are in terms of hertz, we can take H value in terms of hertz. Okay. So here I am taking in terms of joules. The value is 6.626 into 10 to the power minus 34 joule second. Okay. What is the other data needed? Velocity of light. They don't give it in the question. We need to remember this value in terms of meters per second. Okay? So if you want to take the velocity of light in terms of centimeters, you should take the wavelength also in centimeters. Okay? So don't forget to focus on the units. Here I have taken the wavelength in meters. That is why I am taking the velocity of light is also in terms of meters. Okay? Now substitute in the formula. E is equals to H value as well as velocity of light values are substituted. Along with the wavelength of light, we got the value in terms of meters as 6 into 10 to the power minus 7. Okay? Will be cancelled here 2 times. 2 will be cancelled here how many times? Will be 3.313. Right? Got it or now what about the energy? So 3.313 into 10 to the power. What will come? Here if you observe there, minus 34. Okay? Because the bases are the same, so powers I am going to add. Now, when 10 to the power minus 7 comes to the numerator, it will be 10 to the power plus 7. Okay? So how much will you get there? 8 plus 7, 15. Plus 15 minus 34. So we will get minus 19. Correct or wrong? Okay? Understood? So it will be 10 to the power minus 19 units work. We taken the H value in terms of joules. So finally the energy will be in the terms of joules. Okay? Got it? 10 to the power minus 34 into 10 to the power 8. When 10 to the power minus 7 comes to the numerator, it will become 10 to the power plus 7. Okay? Bases are the same, so powers I added. So finally we got the answer as this much. Right? So this is the way of calculation of or calculating the energy using the wavelength. Note down, then we will discuss next question. Okay. Now coming to the next question. A bulb emits a photon A bulb emitted a photon. Photon nothing but light radiation of wavelength 4500 angstroms. Okay, the wavelength of the light radiation emitted from the bulb is given as 4500 angstroms. The bulb is rated as, rate means not the cost, is rated as 100 watt. Okay, a bulb is rated as 100 watt. So capacity of the bulb is given as 100 watt. But 8% of its energy is emitted. Okay, it is rated as 100 watt, but 8% of its energy only emitted. Those emitted radiations wavelength is given as 4500. Okay, so here energy given, wavelength given. Now the question is, find the rate of emission of the bulb. Okay, so it is a previously asked question, so don't confuse with the question. Okay, easy questions, formula substituted questions you are able to solve. As first question if you see, wavelength given, energy they are asking. Okay, and they may give frequency, they will ask you to calculate the wavelength. Okay, so those type of questions you are able to solve. So let us see some typical questions, different model questions. Okay, instead of wasting time by simply substituted model questions, it will be better to discuss the different thing. Okay, anyway if they ask a direct question you are able to solve. Even with first model we discussed, one more question also we will discuss like that. Now if you observe there, wavelength of limited photons given, energy of the radiation is given. Now rate of the emission from the bulb we are asking. Okay, so first doubt is, sir, how to find the rate of emission? Yesterday you did not give any formula to calculate the rate of emission from the bulb per second. Don't confuse with the rate of emission. The rate of emission nothing but the number of photons emitted per second. Okay. Now, what data they given, let us write. The given wavelength is 4500 angstroms. Can we take the value in terms of angstroms? No, we have to convert it into meters. How can we convert? Since we know that 1 angstrom is nothing but 10 to the power minus 10 meters. So now wavelength is equals to 4500 into 10 to the power minus 10 meters. Okay? How much it will be? We can write it as 4.5 into 10 to the power minus 7 meters. Right. Understood? 4500 I written it as 4.5 into 10 to the power minus 7. So it means into 10 to the power minus 3 I have 10. So we got 4.5 into 10 to the power minus 7. It is in terms of meters. Now, what about energy? The first doubt here, they did not give an energy directly as these many joules. Okay, if they give energy as these many joules, normally everybody will able to do the question. Okay, so to make the question typical, instead of giving energy directly, they given it as 100 watt. Maybe in physics you all know that 100 watt means what? 100 watt nothing but 100 joule into second, right? So per second it will be 100 joules. Can you take the energy directly as 100 joules? No. How much they given? They have given that 8% of energy only it emitted. Its capacity may be 100 joules. But how many joules it emitted? Only out of its capacity, 8% only it is emitted. Okay? So how to take 8%? We all know 8% is how much? Out of 100 watt, 8% means 8 by 100. Okay? Right? 100 gets cancelled. So finally we got 8 joules is the energy. Got the logic? Regarding this question, we need to focus on 2 points. The first point is the rate of emission from the bulb is nothing but the number of radiations emitted from the bulb. Okay? And one more thing, 100 watt, nothing but 100 watt, nothing but joules into second. In physics, generally use this conversion. But why we are not taking 100 joules directly? Because out of the 100 joules, 8% of energy only emitted. Okay? So that's why we have taken 8% of 100. Okay? 100 gets cancelled. So we got 8 joules. Right? Now coming to the question. So what is the formula we have? E is equals to NHC divided by lambda. What we need to find here? E given, lambda given, H and C anyway constants. So we need to find N. So the number of radiation or the number of photons emitted is will be how much amount? E into lambda divided by HC. Right? Lambda I have taken this side and HC I got down. Okay? Now substitute the values. Energy how much we got? 8 joules. Wavelength how much we got? They given it as 4.5 into 10 to the power minus 7. Okay? Divided by H. Planck's constant 6.626 into 10 to the power minus 34 into velocity of light 3 into 10 to the power 8. Okay? Got it? E value we already given in the question. Lambda in terms of meters, velocity of light in terms of meters per second, frequency, H value, Planck's constant is taken in terms of joules. Okay? Now coming to the calculation point of view. Here, we know 3 will be cancelling 4.5. How many times? 15 times. Because 3 15s are 45. So in 45, 15 times. So in 4.5, 1.5 times. Okay? So now let us write what values will be. 8 into 1.5. How much it will be? 8 into 1.5 if you do, it will be 12. Sorry, 1. Normally 8 into 15 if you do, 8 15s are 120, right? So 8 into 1.5, it will be 12. So 12 divided by 6.626 into 10 to the power minus 7. Now when 10 to the power minus 34 comes to the numerator, it will be 10 to the power plus 34. Okay? In the denominator it is minus 34. When it comes to the numerator, it will be plus 34. 10 to the power plus 8 when it comes to the numerator, it will become 10 to the power minus 8. Now by adding all those, what we will get? 12 by 6 means 2. So 6.6 will be less than 2 times. So approximately I am taking it as 1.7. Now 10 to the power minus 7 plus 34, this one. How much it will be? 10 to the power plus 19. So these many number of photons will be emitted. So that this is the rate of emission of the bulb. Okay. So somewhere in the notes, while you are copying this, mention that rate of emission nothing but the number of photons, the number of radiation emitted. Okay. So directly formula only. Here we need to remember few points like this one, as well as conversion of watt into joules, as well as if they given 8% of energy only taken, we know how to take the percentage. Then the direct substitution. Okay, those multiplications, divisions you are able to do, right? Copy this. Now, coming to the next type of question. Here, now note on the question. The frequency of radiation required to ionize a hydrogen atom okay, the frequency of radiation required to ionize a hydrogen atom. Here not only a hydrogen atom, let us take any atom, an atom, because somebody may think in case of hydrogen atom this formula, in case of other atom other formula, like that you may think. So that is why the amount of, you may have idea already about ionize. Ionize means what? When it will be ionized, when we remove the electron, it will be gets ionized. Is 3.3 into 10 to the power 8 H. Okay, the frequency of the radiation required to ionize an atom is this much frequency. Now the question is, calculate the ionization energy of the given frequency of radiation. Now they are asking us to calculate the ionization energy of the atom. Okay. So here, okay, they given frequency they given this much. Henry means number of cycles per second. So no need of any conversion regarding this. Okay. Now what they are asking? Ionization energy. We all know about ionization energy. What is meant by ionization energy? The amount of energy required to remove the electron from the outermost orbit of an isolated gaseous element. In the periodic classification of elements, we all know about that. Now, it means we need to find the energy. So here, energy formula what? H mu. Okay. So for one hydrogen, for one atom we are going to find. So E is equals to H mu. Let us substitute the values. It is 6.626 into 3.3. So into is H value in terms of joules. Now, frequency is given as a 3.3 into 10 to the power 8. Okay. So when we multiply, so how much we will get? Energy is equals to 6.6 into 3.3. Normally 3 into 6.6 if you do, you will get approximately 20. So more than 3. So it will be around 22 you will get. Okay. Into 10 to the power. Minus 34 plus 8. It will be minus 26 joules. Okay. So that is the energy of the radiation, so which is required to cause the ionization. Okay. But for example, if the options are given in terms of ionization energy, generally will give in terms of joules per mole. Okay. This is joules per atom. Okay. So for one atom, how much energy required means this much energy is required. Instead of giving this, okay, minus 26 plus 8, 35. Okay. Now, instead of giving the options per atom, if they give per mole, okay. So for one atom, this much energy is required. So per one mole, if you want, what we need to do? Mole means how many? Avogadro number of particles, right? So the total energy should be multiplied with the Avogadro's number, right? So that is one thing we need to remember. That my logic. If the options are given in terms of joules per atom, this is the final answer. If they give the answer per moles, how to convert? Then this is energy per one atom. Per mole, if you want, this value into 10 to the into Avogadro's number. Okay? Avogadro's number how much? 6.022 into 10 to the power 23 if you do. We will get energy per mole. Got it? So multiplications and divisions you can do later. First understood the question or not? They simply asked ionization energy of the atom. So for atom only we expressed. If they ask the energy in terms of mole, okay, then after calculating the energy we should multiply it with the Avogadro's number. Right? Why we multiply it means because one mole means Avogadro's number of particles.